Geometry. Thanks for tuning in for another episode of Math with Mullins. Today we're looking at our quiz review over lessons 5.1, 5.2, and 5.6, which is just a whole bunch of interior angles of triangles, exterior angles of triangles, then determining if a triangle is isosceles or equilateral and how that affects the angle and side measurements. Let's go ahead and get started finding the measure of each angle. For number 1, when I looked at angle 1 right here, I thought of, okay, angle 1 is a part of this bigger triangle. So I have 27 degrees and 90 degrees. So I'm starting with 180 minus 90 and then minus 27. And I'm going to get 63 degrees. So angle 1 is measuring 63 degrees, which then means I could find this angle measure. So 90 minus 63, not 90, but 180 minus 63 minus 70, minus 63 minus 70 is going to give me 47. So this is just one way to find it. So if this is 47 degrees, then 47 take away from 90 is going to give me 43. So 90 minus 47 is equal to 43. So angle 2 is equal to 43 degrees. Again, you could have done it a different way. You could have noticed that right here we're making a linear pair, so this angle could be 110, and then finding it that way as well. Over here, kind of did the same thing. I looked at my bigger triangle first. So I have angle 1, 90, and 43 degrees. So I started with 180 minus 90 minus 43. And that's going to give me 47 degrees. And then I use that information to start helping me with this linear pair. So 180 minus 47 is 133. So angle 2 is 133. And then for angle 3, we could use a few different things. If I know this smaller triangle is ideally 180, 47, and 91, I just took 180 minus 47 minus 91, and I'm getting 42. So that means 42 and take away from 90 is 48. So this third angle would be 180 minus 48 minus 43, and I'm going to get 89 here. Or some of you saw this is a linear pair, so 180 minus 91 gives you 89. Okay. Next up, we're finding the measure of each of these. For number 3, we are learning about the exterior angle. So that means if I add my two non-adjacent angles, x plus 1 plus 93, I can set it equal to my exterior angle. So this is going to give me x plus 94 is equal to 3x. Or if I subtract x from both sides, I'm going to get 94 is equal to 2x. So that means x has to be 47. And to find each measure, I'm going to have to plug 47 back in to find FGH, which is here. So 3 times 47 would give me 141. So the measure of FGH is 141 degrees. Okay, ACB is this angle here. So I'm going to still use my exterior angle method. 5x minus 10 is equal to 2x plus 2 plus another 2x plus 2. So that's 4x plus 4 and equals 5x minus 10. I'm going to use moving variables to the same side. So I'm going to do a little double elimination here, and I'm going to get x equals 14. So ACB, I would be 2 times 14 plus 2, or 28 plus 2, which is 30. So this is 30, this is 30, which means my leftover amount would be, or these two would be 60. So 180 minus 60 is going to give me 120 for ACB. Okay, and then PLK is my exterior angle. It looks like PLK is adjacent to PLN, and that could be 180 degrees. So 2x plus something else is equal to 180. One thing you could also do is, instead of thinking about it that way, is talking about the interior measure of your angle. So 3x plus 90 is going to be equal to the inside of my triangle here, or 3x is equal to 90. So that means x is equal to 30. So if x is equal to 30, that's 2 times 30, which is 60. And then the leftover amount would be 120 for PLK, since that is a straight angle. Okay. 6, finding the value of x. It looks like this is showing it's an isosceles triangle that's being marked. So that means I would take 180 minus 60 and divide that by 2. And that's still going to give me 60. So that means all 3 of my angles are 60, which means all 3 of my sides are equivalent. So then I can say 2x minus 1 is equal to 3x minus 7. Subtracting 2x from both sides, adding 7 to the other side, I'm going to get 6 is equal to x. So just finding the value of x for that one. And then same thing here. This is an equiangular triangle, so that means equilateral for my sides. So 6x minus 5 is equal to 7. Adding 5 to both sides, I get 6x is equal to 12. So that means x is equal to 2. And then for number 8, all these are same sides. That means all my angles are the same. So I could take 180 divided by 3 angles. I'm going to get 60 degrees for each one. So 3x minus 6 is equal to 60. Adding 6 to both sides, I get 3x is equal to 66. So x is equal to 22. Number 9, it's showing that angle TSV. I'm trying to find TSV and SV. I have 60 degrees. I already see that I have 2 equivalent sides. That means I would have 2 equivalent angles down here. Once again, we're noticing though that if I take away 60 from 180 and cut it in half, I'm still left with 60-degree angles. So TSV is 60 degrees and SV is 4 centimeters. Once again, proving it's an equilateral. 10 is also an equilateral, so because I see equal sides, I know my angles will be equal, so all angles will be equal to 60 degrees, so 12x is equal to 60, so that means x is equal to 5. And then JHK, again, this is equiangular, so 180 divided by 3 gives me 60 degrees, and JK is also going to be equal to that 1.7 since we're all sides matching. All right, let's go on the back and do some real math here. Find QR, RS, SQ, and then the measure of angles QRS and SQR. So just basically all the missing pieces. What we'd want to do here is we want to talk about first my points. Q is at -4, -4. R is at 1, 4. And S is at 4, 1. So I'm going to use these and use the distance formula for each one. We'll start with QR. It says round to the nearest tenth if necessary. So to find QR, I'm doing x2 minus x1 squared plus y2 minus y1 squared. So I would say -4 minus 4 squared plus -4 minus -1 squared. Or sorry, -4 minus 1 squared. So this is going to give me -8 squared plus -5 squared, or 64 plus 25. That's going to give me 89 square root, which is about 9.4. Then I found the length of RS. So to find the length of RS, I did 1 minus 4 squared plus 4 minus 1 squared, or -3 squared plus 3 squared, which is 9 plus 9. I'm going to get the square root of 18, which is about 4.2. So RS is 4.2, and then QR is about 9.4. And then my last one, QS, distance, I'm going to take 1 minus -4 for my y's, which would be 1 plus 4. And then for my x's, 4 plus 4, which is 4 minus -4 for my x's. So that's 5 squared plus 8 squared, which is looking really familiar. It's 25 plus 64, or 89, the same thing I got for QR. So that's about 9.4. So we probably already can say this is an isosceles triangle. And then because it's an isosceles triangle, that means the measure of angle QRS should also be equal to 81 degrees. And then 81 times 2 is giving me 162. So 180 minus 162 is going to give me the measurement of angle SQR, which is 18 degrees. So there we go. And then here are my distances, all right here. All right, classify triangle ABC with the common vertices. So again, I took side AB, and then BC, and then AC, and just found the distance for all of those. So for A to B, I did for my Y's 4 plus 2, and then for my X's negative 4 plus 3 squared, so that is 6, and negative 1 squared, or 36 plus 1, so about square root of 37. I don't need to put this in decimal form right now because I can probably just compare my square roots. BC, I did, from B to C, I did 4 minus 3 for my Y's squared, plus negative 4 minus 2 squared. That's going to be 1 squared and negative 6 squared, or 1 plus 36. So again, I'm getting square root 37. So far I've got 2 matching sides. And then for AC, from A to C, I did 3 plus 2 for my Y's, and 2 plus 3 for my X's, and that is 5 squared plus 5 squared, or 25 plus 25, which is going to give me square root 50. So, because I have 2 matching sides, I will name this an isosceles triangle. Next up, number 14, write congruency statements for the triangles and their corresponding parts. So typically, what I like to do is first match my angles. My angles help me write my congruency statements, and then I can do my sides after that. So, noticing that V has 1 arc and so does H. So I'm going to say angle H matches with angle V, and then angle G has 2 arcs. G matches with U, and then F has 3 arcs, and so does T. So H, G, and F. H matches with V, G matches with U, and F matches with T. That's going to help me write my congruency statement. H, G, F is congruent to V, U, T. And then that's easier to write my sides. HG matches VU, GF matches UT, and then HF matches VT. Okay, so once again, we can write the stack, and that really helps to eliminate any confusion or which order my letter should go in. 15, and then one more after this one. In this diagram, JKL is congruent to QRS's triangle. Find the value of X, the measure of R, and the value of Y. So to look at X, I see X here is in this corner with the letter K. And if I write JKL on top of QRS, it says that K matches R. K matching with R, well, here's R, but I don't know what X is equal to yet. So what I would probably do is then decide, okay, well, my other angle 30 is my Q, and Q is matching J. So then I can say, okay, this triangle is 90 and 30, so that's already 120. So subtracting 120 from 180, I get my leftover amount. So that means angle K is equal to 60 degrees. So to find the value of X, I can say 3x plus 3 is equal to 60 degrees, which also means that this one will be 6 degrees, but I'm going to go ahead and find X so I can plug that in there for measure of angle R, which is actually already given to me, 60 degrees. When I solve for X, I'm going to subtract 3 from both sides to get 3x is equal to 57. And then if I divide both sides by 3, I'm going to get 19. So X equals 19 for X. And then you can do one of two things here to find the value of Y. I already know that this is equal to 60, but I'm going to plug in 19 for X. So 2y minus 3 times 19. I know that 3 times 19 is 57. So 2y minus 57 is equal to 60 degrees. Add 57 to both sides. I'm going to get 2y is equal to 117, so that means y is equal to half of 117, or 58.5. Okay, and then our last question in this diagram, JKLM is congruent to WXYZ. So again, I do the stack, JKLM, WX, Y, and Z. Solving for x, x is here, which means KL is matching XY. So I just set 3x plus 9 is equal to 129, and I start to get x by itself. 3x is equal to 120, so that means x is equal to 40. For the measurement of angle L, L corresponds to y, so the measurement of angle L is 58 degrees. And then for angle or variable y is at j, and j corresponds to w. W is equal to 122, so I would just set those equal together. 2y plus 2 is equal to 122 and start to solve. Minus 2 on both sides, I get 2y is equal to 120, and y is equal to 60 degrees, or 60, so y equals 60. And there we have it. So a lot going on with triangles, but for the most part, just really algebra heavy. Not too concerning of how to solve these things, just remembering isosceles means two sides and two angles match, and then equilateral, all sides and angles match. Thanks so much for tuning in. Hopefully this gives you some help for your quiz, and we'll catch you next time. Have a great day. Bye.